The herpes virus may double the risk of developing dementia. People who have had a herpes infection have twice the risk of developing dementia compared to those who have not had problems with this type of infection. A new study by Swedish scientists adds further evidence that herpes may be a risk factor for developing dementia. Dementia, i.e. reduced mental capacity and cognitive functions, mainly affects older people, most often after the age of 65. However, it starts much earlier. Despite decades of research, the exact processes that cause the disease remain a mystery. But it is clear that the aging process leads to changes that fuel its development. Alzheimer's disease is the most common form of dementia. This is a general term for loss of memory and other cognitive abilities severe enough to interfere with daily life. More and more people are suffering from Alzheimer's disease, which is related to the increasing life expectancy. Unfortunately, this disease has now become the 5th leading cause of death worldwide. New research from Uppsala University in Sweden has found that people exposed to the herpes simplex virus type 1, HSV1, are twice as likely to develop dementia. The research lasted 15 years and involved over 1,070-year-olds. The description and results of the research were published in the Journal of Alzheimer's Disease. The herpes simplex virus belongs to the herpes virus family. This family is numerous and contains over 100 species. These are common viruses in animals and humans. The most famous of them are the herpes simplex viruses HSV1 and HSV2. The former, herpes labialis, causes herpes in the mouth and surrounding areas, while the latter, herpes genitalis, causes genital herpes. Herpes simplex virus is a common virus. An estimated 3.7 billion people worldwide are infected. The history of herpes dates back millions of years, with different forms of the virus infecting different species. In a 2022 study, scientists from Cambridge showed that the virus had spread around 5,000 people years ago as a result of large migrations of people from Eurasia to Europe. Infection with the virus lasts a lifetime, but symptoms may come and go at different times. They may also not appear at all. Many people never experience any symptoms related to the infection. The concept of a viral cause of dementia is not new. It appeared at the beginning of the last century. The hypothesis at the time was that Alzheimer's disease was a slow viral disease, in which one or more viruses steadily degraded neurological processes in the brain after several decades of dormancy. It seems to be confirmed by research. In 2018 work, researchers at the Icahn School of Medicine found that the brains of people with Alzheimer's symptoms had twice the levels of herpes viruses compared to healthy people. In turn, in analyses from 2022, scientists from Tufts University and the University of Oxford linked the development of Alzheimer's disease with infection with the VZV virus, varicella zoster virus, which can activate the common HSV1 viruses hidden in nerve cells, which in turn may promote the deposition of beta-amyloid plaques and thus lead to the development of Alzheimer's disease. In a new study, scientists from Uppsala University monitored the health of over 1,070-year-olds for 15 years. 82% of subjects had HSV1 antibodies. This work showed that people who were infected with the herpes simplex virus at some point in their lives were twice as likely to develop dementia compared to people who were never infected. This association held regardless of the two strongest predictors of Alzheimer's disease currently known: age and having a genetic variant called APOE4. It is exciting that our results confirm previous work. These studies, like our findings, show growing evidence that the herpes simplex virus is a risk factor for dementia, says Erika Weston from Uppsala University. Important conclusions from the study include the need for further analyses. Perhaps already known drugs against the herpes simplex virus may reduce the risk of developing dementia and provide opportunities for the development of new drugs. The results could push further dementia research toward treating the disease at an early stage with commonly used anti-herpes drugs, or preventing the disease before it occurs, Weston added. The Kuiper belt may be much larger than previously thought. Data from the New Horizons spacecraft indicate that the Kuiper belt, the vast outer zone of our solar system, may extend much further than previous estimates suggested. Flying through the outer edges of the Kuiper belt, nearly 60 times farther from the Sun than Earth, New Horizons science instruments detected higher than expected levels of dust, the tiny, frozen remnants of collisions between larger bodies in the Kuiper belt, known as Kuiper belt objects, KBO. These readings contradict scientific models that the KBO population and dust density should begin to decline at this distance from the Sun, and suggest that the outer edge of the Kuiper belt may extend billions of kilometers farther than current estimates. Another option is that there may be a second lane beyond the one we already know. The results and description of the research were published in the Astrophysical Journal Letters. The Kuiper belt is located beyond the orbit of Neptune. It is very similar to the asteroid belt located between Mars and Jupiter, except that it is much wider and more massive. It contains countless small objects that are remnants of the formation of the solar system. In addition to space debris, there are 3 dwarf planets orbiting there: Pluto, Haumea and Makemake. At least we know about these 3. Unlike the asteroid belt, where rock and metal objects orbit, the Kuiper belt is mostly composed of objects composed of solidified chemicals, such as methane and water. The Kuiper belt begins roughly beyond the orbit of Neptune, about 30 astronomical units from the Sun. Astronomical unit, O. 1 O is a distance equal to the distance of the Earth from the Sun, about 150 million kilometers, and was previously thought to extend to a distance of about 55 astronomical units. NASA's New Horizons spacecraft was designed to explore the outer parts of the solar system. In 2015, it flew by Pluto, which orbits the Sun at an average distance of 39 astronomical units, providing the first detailed images of the distant dwarf planet and its moons. In 2018, it reached Ultima Thule, also known as 486958, Arica, which orbits the Sun at an average distance of 44.6 astronomical units. It is currently located approximately 57 to 58 astronomical units from the Sun and continues beyond the boundaries of the solar system. During its 18-year journey, the probe constantly collected data and transmitted it to Earth. Scientists expected that the amount of dust would drop dramatically after passing the Kuiper belt, but this did not happen at all. The dust detector continues to detect much more dust than scientists expected to find at this distance. The New Horizons spacecraft makes the first direct measurements of interplanetary dust far beyond the orbit of Neptune and Pluto, said Alex Donner from the University of Colorado at Boulder, lead author of the paper. The idea that we could detect an extended Kuiper belt with a whole new population of objects colliding and producing more dust provides another clue in solving the mysteries of the most distant regions of the solar system, he added. The spacecraft's Venetia Burney Student Dust Counter, SDC, instrument detected microscopic dust grains produced by collisions between asteroids, comets and other Kuiper belt objects at a distance where scientists thought the spacecraft had already passed the Kuiper belt. SDC counts and measures the sizes of dust particles, providing information on the frequency of collisions between such bodies in the outer solar system. Observations using ground-based telescopes appear to confirm the data collected by New Horizons. Using ETiMM, astronomers have also discovered a number of KBOs far beyond the traditional outer edge of the Kuiper belt. The boundary where the density of objects and dust began to decline was previously thought to be around 50 to 55 astronomical units away. But new evidence suggests that the Kuiper belt may extend to 80 astronomical units or even further. The data collected by New Horizons means that additional dust must be produced where it is located, or solar radiation forces are pushing dust from areas of the known Kuiper belt into this space. The first option means that there must be enough objects for their collision to generate dust. The new scientific results obtained by the New Horizons probe may be the first time a spacecraft has discovered a new population of objects in our solar system, said Alan Stern, principal investigator of the New Horizons mission from the Southwest Research Institute in Boulder. I can't wait to see how far the elevated dust levels in the Kuiper belt extend, he added. According to estimates, there should be enough fuel to keep the probe operational until 2040. During this time, it should exceed a distance of 100 astronomical units from the Sun. Scientists say that this far away, the SDC could potentially record the spacecraft's passage into an area where the dust environment would be dominated by objects or interstellar dust from outside the solar system. An antivenom has been created that neutralizes the venom of several dangerous snake species. Scientists have identified a versatile antibody that protects against deadly venom from various species of snakes. In tests, it protected mice against the venom of the Nepalese cobra or black mamba. This is a big step towards developing a universal antivenom that would be effective against the venom of all snakes. Scientists have identified a powerful antibody that can neutralize a key type of neurotoxin produced by several dangerous snake species in Africa and Asia. They emphasize that based on their work, it may be possible to develop antivenoms that can be used against any of the world's poisonous snakes. We are eliminating a major subclass of neurotoxins, says Nicholas Casewell from the Liverpool School of Tropical Medicine. I think this is a really huge step in terms of what can be achieved with a single antibody, he adds. The description and results of the research were published in the journal, Science Translational Medicine. This antibody works against one of the main toxins found in many snake species and responsible for tens of thousands of deaths each year, said Dr. Joseph Jardine of Scripps Research. This could be extremely valuable for people in low and middle income countries where the highest number of snakebite deaths and injuries occur, he adds. Venom is a cocktail of proteins that animals use to immobilize and kill prey, as well as for self-defense. It occurs in many different animals: jellyfish, spiders, scorpions, snakes and even some mammals. It is introduced into the victim's body using teeth, spines or stingers. Snake venom is a mixture of dozens or even hundreds of compounds that attack nerve cells, tissues or affect blood clotting. Every year over 100,000 people around the world die from snake bites. But some animals that have venomous snakes in their menu are hardy or resistant to the effects of a specific venom. The standard treatment after a snake attack is antivenom. Although these drugs save lives, they also cause many problems. Snake venom varies greatly depending on the species. Therefore, the form of treatment will depend on which snake is responsible for the bite. The problem is that in many cases it is not known which species of snake it is. But venom can vary even within the same species. As Kartik Sunagar from the Indian Institute of Science, co-author of the publication, admitted. The antivenom used after the bite of the Nepalese cobra, Naja Kayathea, is ineffective in some regions of India. Many antivenoms work against several snakes from the same region, but have weak activity against other snakes. Sunagar explained that, as with the Nepalese cobra, one of the antivenom cocktails commonly used in Africa is ineffective for 1 in 7 people bitten by a black mamba, Dendroaspis polylepis. Moreover, antivenoms containing specific antibodies are obtained by immunizing animals with snake venom, and because these drugs are made from animal proteins, they can cause unwanted immune reactions, including life-threatening anaphylactic shock. In an attempt to develop a new antivenom, Sunagar teamed up with Casewell and Jardine. In the study, scientists isolated and compared venom proteins from various venomous snakes, including mambas and cobras. They noticed that a certain type of protein, present in all snakes in the snake family, which also includes mambas and cobras, contained small fragments that looked similar between species. Jardine's team coaxed cells grown in the lab to produce the discovered protein, a key component of the venom of many snakes from the three-toed toxin, 3-FTX, family of proteins. These toxins cause paralysis by blocking the ability of nerve cells to respond to a key neurotransmitter. In the next step, the researchers searched a huge database of human antibodies to see which ones best bind to these toxins. This resulted in the identification of several dozen promising candidates. The identified antibodies were sent to Caswell's group. His team checked how well they protected human cells against the toxin. An antibody called 95-MAT5 showed the best effectiveness. It bound to alpha-bungarotoxin, the main 3-FTXL protein found in the venom, in exactly the same place where the toxin binds ion channels in human nerve and muscle cells. Once you've identified the best candidate, it's time for testing. Scientists gave rodents a usually lethal dose of alpha-bungarotoxin and the 95-MAT5 antibody. All mice survived. There was no paralysis. 95-MAT5 also rescued mice injected with the full venom of the banded ragweed, Bungarus multicinctus, which is believed to contain dozens of different toxins. The compound helped even when administered 20 minutes after the venom. The same applied to the venom of the Nepalese cobra and the black mamba. 95-MAT5 proved ineffective against king cobra, Ophiophagus hanna, venom. The rodents died, but researchers emphasized that the antivenom significantly delayed their death. 95-MAT5 could complement existing antitoxins that are not very effective against the 3-FTXL protein. And because the antibody is human, it is less likely to cause unwanted side effects. The team plans to use the same process to identify antibodies to other potent snake toxins. The goal is to create a cocktail that will neutralize the venom of every dangerous snake living on Earth.